Bernardo, the plan for this episode is to introduce our audience to a new emerging technique in the realm of LLMs called model merging. You've been digging deep into this in the past few months, so do you want to introduce us to the concept?
Yeah, I've been reading a lot about model merging techniques, how it works in practice. And the idea is quite simple at a high level. It's a basic concept. Basically, you try to combine different models into a single one. And you want to retain the abilities of each of those models involved in the merge in the model that you are producing.
Is it just a new term for model ensembling, or is it a completely new concept?
No, it's different actually. In model ensembling, basically what you are doing is combining the outputs of different models to find like a more accurate prediction or output. But that means that you need to keep all those models at inference and obviously maintain them and deploy them. And you also need a strategy for combining those outputs. Let's say that you are consult different experts about different domains, and then you kind of gather all the insights and synthesize a response, basically. So that would be model ensembling. In model merging, what you do is you merge the weights of different models into a single model, and that means that there's only one model involved at inference time because you've merged all the weights into the same architecture. If we continue with the expert analogy, it would be like learning from all these experts, and then one single expert can answer questions about all those topics, but you don't need to consult all the experts every time that you need to basically answer a question.
What can you actually do with model merging?
Yeah, there are different use cases. One of the main ones is converting single task individual models into a multitask model. So let's say that you have a model that is really good at question answering and another model that is really good at summarization. You would merge them and convert them into a multitask model that can do both tasks very well. And you can do this without additional data or compute. You don't need to train. It's not a gradient-based technique. You don't need to update the model's parameters. So that's one of the main advantages.
I could also imagine it coming to play with domain adaptation. So if you have a general purpose model and you want to make it more powerful at specific or domain specific tasks, is that correct?
Yeah, the other way around as well. You could have a domain specific model and you might want to give it some chat capabilities, right? Yeah, I think that's perfectly possible. And good example is, for example, the BioMistral paper. So there they took Mistral 7B model and they adapted that model to the medical domain, biomedical domain specifically. And then they use Mistral Instruct, which is a fine-tuned model for chat. And then they merge those models. And then they had this domain-specific model also with chat capabilities. And they also saw that actually having that model with chat capabilities increased the metrics on the medical benchmarks as well, because kind of the model has a little bit more kind of reasoning abilities after that merge. It's also possible when it comes to domain adaptation to train a smaller model in a domain-specific corpus. So you need less data for training that smaller model, and then use model merging to add that knowledge to a bigger model. So you train that smaller model and then you merge it with a bigger general purpose one, and that would save a lot of compute and resources.
What kind of resources are we talking about here? Not just in terms of human resources, but also computation and data.
Yeah, mainly computation and data, as you said. So when you are fine-tuning a model, for example, you need GPUs and you need data as well. The idea of merging models is creating better models without the need of spending a lot of money on compute and without the need of creating more data or annotating more data. So it's about reutilizing all the work that has been done already, and so we don't have to kind of start from scratch. It could be seen as similar to transfer learning in the same way that you have a pre-trained model and then you fine-tune it. So by merging models, you could also develop a better model without spending anything on GPUs or more data, for example.
Makes sense. To me, model merging sounds almost too good to be true, especially considering how little talked about the concept is within the community. But have we seen any good examples of the community creating models with the model merging techniques?
Yeah, I should say that it's becoming like more and more popular, to be honest. It's true that model merging has its limitations as well. So yeah, we should consider that. But we've seen like really good merge models. A recent example was 120V Llama model created from Llama 370V by Maxime Labon, if I'm not wrong. So basically what he did was he took Llama 70V and then he basically concatenated different layers of that model to create a much bigger model with more depth, and that produced really good, a really powerful model. Sorry. We've seen also many merge models leading the OpenLLM leaderboard, although we know that there are some issues with those benchmarks, but we've seen like powerful models, like models that were much more powerful than the individual models that were used in the merge. So yeah, even it's becoming more popular, has its limitation. I would say one of the major limitations is that you might not find the right models for your tasks, and that means that you don't have anything to merge. So if you are after a very specific task, it might be that that model is not available, and then you cannot really improve it by merging because obviously it's not there. I would say that in the future we'll see many more specialized models, and then model merging will probably become much more popular. So yeah, those are, I would say, one of the reasons. I should say that there are many good examples of successful merges.
Yeah. You mentioned that the workload that goes into creating a merge model is not really a big consideration, right? But what goes into actually creating that merge model?
Yeah, like the workload in terms of computation or data, that's not significant. I mean, you can merge models with a normal CPU, 8 GB of RAM, so nothing too crazy. I think that the major problem is finding the right, as I said, finding the right models to merge based on your requirements, and also the right settings as well. I think that's where you would spend most of your time when trying to find a good merge.
Yeah, there are a few different methods to the actual model merge. So can you talk a little bit about those?
Yeah. There are, I would say, like 4 very popular methods. There are more, but I'll just mention these ones. One is called like linear method or model soups, and the idea is just to average the weights of the model. It could be a weighted average as well. It's pretty simple. And the authors of the paper did it in the context of accelerating training. So they were merging different checkpoints of a model to get to a much better model faster without spending so much money on training. Then there is a very similar method called SLERP, so spherical linear interpolation, that you could use for making only 2 models. You cannot merge more than 2 models, and the idea is like to create like a smooth transition, a smooth interpolation between the weights of those models. It works quite well in practice when you have only 2 models. And then there are methods based on task vectors, so task arithmetic, and then there's task merging, and there. A task vector is basically, like in simple terms, is like the difference in the weights between the fine-tuned model and the pre-trained model that was initialized at the beginning of the fine-tuning. And then what you do is you compute that task vector, and then you could do operations with them. And normally, if you want to add more abilities to the model, you add them together, and then you kind of put them back into the pre-trained model. And in this way, you change like the behavior of that initial model. And then the other 2 methods that are based on this, that I already mentioned, there and TIES, they try to address possible interferences in the model parameters. For example, a possible interference is that the sign of one vector is different from the other one, then what do you do? What they basically do is like they prune a little bit the task vectors, and then they try to address those interferences. Finally, there's like quite an experimental method that is called layer stacking or Frankenmerging. And there what you are doing is just concatenating layers, creating a new architecture. So you could say, I want 5 layers from this model, then I want 8 layers from this other one. And that results in quite exotic model sizes, like 160 billion parameters. Normally, you know that we have 70 perhaps 34 billion parameters, then 70 billion parameters. But then if you do these Frankenmerges, then it's going to result in, I don't know, like 64 billion parameters. It's quite experimental, but we've seen like really good models produced by this technique after running many experiments. One really good one is Goliath 120V MiQ as well. So yeah, very interesting. And more recently, for example, there's a new approach to model merging by Sakana AI, and it's called evolutionary model merging. So the idea is to apply evolutionary algorithms to this technique. So you would have like this evolutionary algorithm that tries hundreds of different combinations of layers and merging methods as well. And then it tries to automate foundational model development. I think that that's very, very promising. I'm really looking forward to seeing more research in that direction.
So Bernardo, have you done any model merges yourself, and what kind of experiences have you had?
Definitely. I pretty much tried all the methods, all the popular methods. I wouldn't say that a method is better than another one by itself. What I do recommend is that if you have only 2 models, just start with the SLERP, spherical linear interpolation. If you have multiple models based on the same backbone, on the same pre-trained model, start with ice merging with kind of some default parameters that you could get from the paper. You don't even need to get them from the paper, because actually we worked on an open source library called FlowMerge that we made public a few weeks ago. Because as we were working on this, we found it like super interesting and inspiring, and we decided to create this Python library for everyone, for the community, to basically run model merges. So it's called FlowMerge, open to contributions, and there we have basically all the most popular merging methods, like the ones that we mentioned. Yeah, we are planning to add more as well as they are released and they are like somewhat tested. And yeah, I think it's very, very exciting direction for the LLM kind of community.
Sounds good. Let's wrap up there. Thanks, Bernardo.
Thank you, Aro. Thank you very much.